The other way of calculating sine 18 is to use trigonometry. So what we can do is we can let x equal 18 degrees. And because 18 is a factor of 90, what we can say is that 5x is equal to 90 degrees. And now, what we can do is break up the 5x into 2x and 3x. So we can say that 2x plus 3x is equal to 90 degrees. And so we can bring one of the terms onto the other side to get 2x is equal to 90 minus 3x. Great. If we take the sine of both sides, we get that sine of 2x is equal to sine of 90 minus 3x, which we can rewrite as cos of 3x. Now we're going to use a couple of trig identities. So we know that sine of 2x can be expanded to 2 sine x cos x, and we know that cos of 3x can be written as 4 cos cubed of x minus 3 cos of x. So using these substitutions, we're going to get that 2 sine of x cos of x is equal to 4 cos cubed x minus 3 cos of x. Now I'm going to bring everything onto the left-hand side. So I'm going to get 2 sine of x cos of x minus 4 cos cubed x plus 3 cos of x is equal to 0. Taking out a factor of cos of x, we get cos of x times 2 sine of x minus 4 cos squared x plus 3 is equal to 0. Now our goal is to find sine of 36 degrees, which is equal to sine of 2x. I can divide both sides by cos of x because cos of x is actually just cos of 18 degrees, and cos of 18 degrees is not 0. So by dividing both sides by cos of x, which is cos of 18, I'm dividing by a non-zero number, which is perfectly legal. So I get 2 sine of x minus 4 cos squared of x plus 3 is equal to 0. I'm now going to rewrite cos squared of x using the Pythagorean identity. So 2 sine of x minus 4 times 1 minus sine squared of x plus 3 is equal to 0. Expanding, I'm going to get 4 sine squared of x plus 2 sine x minus 4 plus 3 is equal to 0, which I can simplify to 4 sine squared x plus 2 sine x minus 1 is equal to 0. Now, this is just a quadratic in sine of x, which I just need to solve for sine of x. So, using the quadratic formula, sine of x is going to be minus 2 plus or minus square root of 2 squared minus 4 times 4 times negative 1, all divided by 2 times 4, which is 8. This is minus 2 plus or minus square root 4 plus 16 over 8, which is minus 2 plus or minus square root 20 over 8, which is minus 2 plus or minus 2 root 5 over 8, which is minus 1 plus or minus root 5 over 4. Now, because x is 18 degrees, that means sine of 18 is a positive number because 18 degrees is in the first quadrant. And so, therefore, we know the exact value of sine of 18 degrees. That's equal to minus 1 plus, taking the positive value, square root 5 over 4. Now, we can use the double angle formula for cosine to work out cos of 36, and then use the Pythagorean identity to work out sine of 36. So, using the well-known formula that cos of 2x is equal to 1 minus 2 sine squared of x, what I can say is that cos of 36 degrees is equal to 1 minus 2 sine squared of 18 degrees, which is equal to 1 minus 2 times root 5 minus 1 over 4 all squared. This is equal to 1 minus 2 times 5 plus 1 minus 2 root 5 over 16, which is equal to 1 minus 2 outside of 6 minus 2 root 5 over 16, which is 1 minus 2, 3 minus root 5 over 8, 1 minus 3 minus root 5 over 4, which is 4 minus 3 plus root 5 over 4, which is 1 plus root 5 over 4. Finally, we can work out the exact value of sine of 36 degrees using the Pythagorean identity. That's the square root of 1 minus cos squared of 36 degrees, which is the square root of 1 minus 1 plus root 5 over 4 all squared, which is the square root of 1 minus 1 plus 2 root 5 plus 5 over 16, which is 16 minus 1 minus 2 root 5 minus 5 over 16, all square rooted, which is 16 minus 1 is 15, minus 5 is 10, minus 2 root 5. I'm going to take the square root of that over 4. And that's exactly what we got using the polygon method as well. And so that's the answer to part A.